Welcome to the next class of data communication networks. So today we will be talking our second unit called data link layer. In the previous unit, we tried to understand the introduction to data communication network, the different types of networks, the fundamental terminologies, then the types of topologies. Then we tried to categorize the two models to understand the networks, which is called OSI model and TCP/IP model. Then the different types of addresses used in different layers of OSM model. Then we try to understand one of the important wireless LAN protocol called IEEE 802.11, right? So we were talking about fundamentals related to the networks as well as the physical layer. Now coming to the second unit, which is data link layer. This layer is present between the physical layer and network layer of OSI model. The data link layer receives the data from network layer, converts it into frames, and then forwards to physical layer. Along with this, we are going to understand the various functions performed by the data link layer. We would start this unit with the starting called what are the various introduction to the link layer and the brief about the services provided by the link layer. Then we'll start a first very important function of data link layer called error detection and error correction, which is together called as error control. So in this topic we'll try to understand what do you mean by errors, what are the different types of errors, then what do you mean by error detection, and what do you understand by error correction, what do you mean by redundancy. Then we'll try to understand different error detection and error correction techniques, particularly the parity check. Then we'll have a cyclic redundancy check. We'll discuss about checksum. We'll also discuss about Hamming codes. And after this, the one more important function delivered by the data link layer is called framing, which we'll be trying to understand here. The next important function performed by data link layer is called flow control, which is trying to ensure the data sent from the sender will not be overflown at the receiver. So what are the different types of flow control techniques we have? When the channel between the sender and receiver is either a noiseless channel where there is no loss of data, or a noisy channel where there is a loss of data. Then we'll try to talk about an important protocol used in data link layer called HDLC. Then one of the other important function performed by the data link layer is called multiple access control. And for that we are going to use a protocol called multiple access protocols. So there we have different types of multiple access protocols called random access, which consists of Aloha, which is classified into two types, pure Aloha and slotted Aloha. Then we'll talk about controlled access, and then we'll discuss about the channelization protocols, namely TDMA, FDMA, and CDMA. Then we also learn about carrier sense multiple access and the versions of carrier sense multiple access. Last but not the least, we will try to understand the MAC protocol of IEEE 802.11, which we have introduced in unit number 1 along with its frame structure. I hope definitely after understanding all these topics, you will get a clear note of what exactly the data link layer and what are the different functions performed by a data link layer. Let us start with the introduction to link layer. What is data link layer, or is simply called as link layer, and what are the functions performed by it? Let us have a quick glimpse. Now link layer, the terminologies that we need to understand are in a network, the different types of the hosts and the routers which are used to connect. Where routers will be used to connect the different hosts spread across the globe. So these are referred as the nodes. The communication channels that are trying to connect this host and the routers, we are referring it as communication path. In the first unit we have discussed that the communication path can be a wired link or a wireless link. And a group of devices connected together, we can refer it as a local area network based on the distance covered or the number of systems connected to that network. So as we discussed, The data link layer receives the data from network layer, which is in form of datagrams or packets, and converts it into frames. And one more important function delivered by data link layer is if the source and destination are spread far distance and in between we are using some intermediate nodes. For instance, this simple example, here you have a source and this is the destination. In between you need to use different types of routers to reach from source to destination. So the delivery from the first source to the router 1 to 2, 1 2 to 3, 3 to 4, 4 to 5, and 5 to 6, and finally 6 to destination. All these transmissions will be referred as node to node delivery or physically adjacent deliveries. So data link layer has this one more important role in communications. And the datagrams transfer by the different link protocols or different links, right? So first we'll try to and one more important thing that we need to understand here is, so in the network we may have different types of links to be used. First instance, in the previous slide we tried to show source to destination we may have some intermediate devices. So first, between source to router 1 may have Ethernet on first link, next we may use frame relay, and next we may have a wireless 802.11. So different links can be used to connect the source and the destination, and each link will be providing different types of service. For instance, here we are taking a simple example of how we are traveling from a place called Princeton to Lausanne. For instance, we don't have a direct transport facility from Princeton to Lausanne. What happens then? First, we'll try to take an own vehicle or a facility like limo, means road transport from Princeton to JFK, which is an intermediate place. We combine this. Then we take a flight from JFK to Geneva, and then from Geneva to Lausanne, we are going to get a train. So here you could find for different destinations, we are using different types of transport mode. Like here we are using for a direct, we are not having a direct link between source and destination. Between we are trying to use different types of links. That is what we are trying to understand. The person who is traveling will be referred as a datagram because that is the data what we want to transport. And the link is nothing but the communication link. The path we are traveling can be referred as the communication link. And the mode of transportation is called the protocols we are using, like Ethernet, like similar to a bus or a car transport, road transport. Frame relays, we can refer it as planes, and then IEEE 802.1 wireless link, like a train, right? So the travel agent is nothing but the routers, which are helping us to travel from source to the destination, right? Coming to the various services provided by the link layer, as we introduced, we are going to receive the data from the network layer, and the datagram is going to be converted into frames. And this process of encapsulating a datagram into frame and then adding an header and trailer to that datagram and converting it to a frame is called as framing process. And one more important function which is performed by data link layer is, if there are more than one device and the channel is unique, then that particular channel is shared among multiple devices using this multiple access protocols. And one more, the address which is associated with the data link layer is called the MAC address, and the MAC address is responsible for the node to node delivery. And MAC address is different from the IP address which is associated with the network layer. And the important functions performed are node to node delivery, framing, multiple access protocol, and for node to node delivery we are just generating a MAC address. Okay, so we learned how to do all. So we can have wireless link or some other like wired links like optical cables or twisted pair. The next important function which is performed by the data link layer is called flow control. As we said, a source may be ready to send a lot of bulk data, but if the receiver is not ready, there will be an overflow of the content. To control that, we will have a flow control mechanism. Then, as we said, The two important functions which are performed in the data link layer are whether there is any error in the transmission of data from source to destination. Identifying only the presence of error is called as error detection. Once an error is detected, if you are trying to rectify and correct the error, that will be referred as error correction. So, and also we are also trying to ensure whether the type of transmission which is being implemented is being using half duplex or full duplex. So these are the different services which are performed by the data link layer. So far what we have tried to understand is what do you mean by data link layer. Next we try to understand what are the different services provided by the data link layer. And one of the more important functions, as we mentioned, performed by data link layer is the flow control, and second one is error control. If you will try to put together the both functions called flow control and error control, that will be referred as data link control. Okay, so what do you mean by flow control? A flow control refers to a set of procedures which are used to restrict the amount of data that can be transmitted, that a sender can send before waiting for the acknowledgement from the receiver. So how much data can I send before I wait for a confirmation from the receiver? That will be decided by the flow control process. And then error control is a process in which there is an automatic repeat request, which means nothing but if I am transmitting data and I don't get an expected acknowledgement within my time frame, then it indicates I have to retransmit the same. Or there is another mechanism where if an error is generated at the receiver, instead of asking the sender to retransmit, the receiver itself would try to correct the error. The first case is called as forward error correction, whereas the other case is called as backward error correction. So here, the flow control decides how much of the data has to be sent and how much I can send before I wait for the acknowledgement. And error control is trying to indicate whether the data transmitted is correct or not, or else I have to go for the retransmission or not. And these two together are referred as data link control. First, I have been talking here about error detection and error correction. Let us first try to understand what do we mean by an error. So error is nothing but when a data which has been transmitted from source to destination, but it got corrupted during the transmission. Now that means if I am sending a data as a bit 0, but because of the different factors, the data is received as 1. That is referred as error. So what is happening is some of the applications which we use would like to ensure there are no errors generated, and that in case if it is generated also they have to be detected and corrected. So first let us try to understand what do you mean by error, what are the types of errors, then we'll try to understand the various error detection and error correction techniques. So if data is corrupted during the transmission, that would be referred as an error. And we want to not only detect the presence of error, but also we have to correct the error. Right. So generally the reasons for the generation of errors could be the interference that happens during the transmission. Now type of errors which are generally happening in data communications are classified into two types. Suppose I have transmitting 10 bits of data or simple 5 bits of data. I have sent 1 0 1 0 1, but because of some kind of interference generated, I have received the data as 1 0 1 0, and last bit got affected and I have received this as 0. So total transmitted data was 10101, but the received data was 10100. So here only one bit got affected, which we will be referring it as If only one bit got, okay, let me erase this. So we were talking about 10101 received as 1010C. Then only one bit got affected. That would be referred as a single bit error. So this case will be referred as single bit. Only one bit of given data you need to change it from 1 to 0, or sometimes it can be like, so instead of 10101, it might have been converted as, let me just use this eraser, and here it has changed as 1001. So in the previous case 1 got changed as 0, and now the 0 bit has been changed to 1. This is called single bit error. But sometimes what happens is there is a possibility that more than one bit got corrupted, and because of this there will be a more than one bit in which there is a difference in the transmitted and receiver. So here 10101 was transmitted and we have received 10110. 0 got affected as 1 and 1 changed it as 0. This process is called error generation, and when number of bits of error generated is more than 1, we call it as burst error. Now, to overcome this errors generated in the transmission, what we are trying to do is, along with original data that has to be transmitted, we are trying to add some extra bits. We are going to add some extra bits to the actual data. Now, adding of these extra bits, so let me first write down this. We are going to add some extra bits, and here along with this 5 bits, if I am trying to add something like, along with this 5 bits I am adding one more bit like 1. So instead of 10101 I am going to add 10101 plus extra bit called redundant bit. So this process is called redundancy, and adding extra bit, those particular bits will be called as redundant bits. So we are going to discuss about what do you mean by redundancy, and how many bits to be added along with the actual data. So original data what we are transmitting will be referred with a word called data word, and after combining the redundancy bits to the data word, that will be together called as code word. So we will be talking about redundancy in the error detection and error correction techniques. Let me erase all the things that we have written so far. I hope we are understanding what exactly we are trying to discuss here. Single bit error, as we have shown earlier, the data transmitted was 0000010, but the data received was 00001010. So 0 here has been transmitted as 1. So number of bits that got interfered and damaged is only 1 bit. So you call that process as single bit error. For this point, there may be another scenario where the 1 will be changed as 0. Okay, so if only one bit got changed, we call it as single bit error. As we said, if there is a change in more than one bit, so if the original data was 010, 100, 010, 00011, and here you find in the received bit a 0 got changed as 1, 0 got changed as 1, 0 got changed as 1. So more than one bit got corrupted and changed from 0 to 1. So this process is called burst error, because number of errors in this scenario is more than 1. I hope people have been understood what do you mean by error and types of error. If a bit of 0 changed as 1 or bit 1 is changed as 0, it is called error. If there is only one instant where this happens, It is called single bit error. If the more than one bit got error because of the interference, that will be reported as burst error. Right. Let's talk about what does difference between error detection and error correction. For this, we'll take a simple example of the way an invigilator observes a student. Suppose you are trying to do some mistake in the exam. Then I know that I am an invigilator and I know that you are doing wrong. But here, the hardly thing I can do is I can say that your problem is wrong. But I will not tell you where the wrong is and what has thing to be done to be corrected. But if the same thing happened in a regular classroom, and I observe your notes and you are trying to do the problem in a wrong way. I'm not only saying that your problem is wrong, I'll try to help you in correcting the error. The first scenario in the exam hall, I call it as simple error detection. And in this scenario of classroom, I can refer the process as error correction. Got it? So error detection is only trying to look only to see if any error is occurred or not. And I can say a simple answer. There is no error or maybe there is an error. But error correction is not only identifying that there is error or not, but trying to correct the error. Here we have two types of error correction, forward error correction and reverse error correction. As we mentioned in the beginning, if the process in which the receiver itself is trying to guess the message and try to correct by using the redundant bits, means I am not looking for retransmission. I am trying to correct the error by myself. That is called forward error correction. If I am looking for sender to retransmit the same data since an error has been detected, that will be referred as backward error correction or retransmission. Okay, so we have detection, which simply indicates whether there is error or not, and correction not only indicating the error but also tries to correct the error. Here we have two types, forward error correction and retransmission. Right. Now here let us have to try to understand how this error detection and correction process happens. Before this, let us recollect one of the definitions which we have given in the beginning for redundancy. Redundancy is a process in which you are trying to add some extra bits along with the original data for the purpose of error detection and correction. Now let us try to take this simple encoder and decoder. Let us look at the simple process where you have the message which is called data, and using this existing message we are trying to generate some redundant bits, and after generating the redundant bits we are trying to combine the message along with the redundant bits and try to send to the receiver. Okay, now at the receiver we are going to receive the data which is a combination of message plus redundancy bits. From this, we are trying to verify if there is an error generated during the transmission or not. If the checker device is identifying any error, we will be discarding it. If it is not finding any error, then it will try to separate the redundant bits from the message and will transmit the message to the next layers. When you're trying to combine message with the redundant bits, we call it as encoding. And when you are separating the redundant bits from the message, we are going to refer it as decoding. And here we are not talking about any correction, just trying to do a simple process of error detection, whether data is correct or not. If it is correct, forward to the next higher layers and read the message. If there is an error detected, then discard the message. This is a simple diagram of an error detection circuit. In error detection and correction, we are going to use one of the important operation called modulo n arithmetic, which is nothing but an exclusive OR operation. Generally what happens is, if you are trying to use a modulo n arithmetic, we will have, if I am using modulo 2 arithmetic, then I am going to have 0 and 1. if I'm using a mod 5, so I'm going to have 0 to 4. So for n modulo arithmetic, we are going to have possible values in the range of 0 to n minus. Let us take a modulo 2 arithmetic, which is simple exclusive OR operation. Let us know the rules of this exclusive OR. If both bits are 0 and 0, then 0 exclusive OR is 0. Similarly, if both bits are 1s, 1 exclusive OR 1 is 0. If two bits are different, that is 0 exclusive OR 1 equal to 1, 1 exclusive OR 0 equal to 1. So in modulo 2 arithmetic, where we are using exclusive OR operation, the two bits are same, then the result is 0, and if two bits are different, the result is 1. Let us take a simple example of the first value is 10110 and second value is 11100, and we are trying to do the modulo 2 addition of it. Following the rules, first we'll start with 0 and 0. 0 exclusive OR 0 is 0, 1 exclusive OR 0 is 1, 1 exclusive OR 1 is 0, 0 exclusive OR 1 is 1, and 1 exclusive OR 1 is 0. Right? So we are going to use modulo n arithmetic and modulo 2 addition process for our error detection. Right. So this is how the modulo 2 addition is implemented using an exclusive OR operation. This will be very useful in error detection and correction. Right. So first, in understanding error detection and correction, let's try to understand what do we mean by concept called block code. Okay. So here what we try to do is, if I am having a bulk data, for instance 50 bits, so what I'm going to do is, first I'm going to divide the total 50 bits into smaller units, each of length 5 bits. So totally I'm going to divide it into 10 portions or 10 parts, each part consisting of 5 bits. Okay. Now this is called, each individual part will be referred as block. Okay. So the total message which we are having is going to be divided into smaller units called blocks. Now for this 5 bits of data, the 5 bits which I am going to refer is called data word length, and this 5 bits together is called a data word. So the total message which we have is going to be divided into smaller units called blocks, and those blocks are referred with a word called data words. And to this data words, I'm going to add some redundant bits, means the extra bits which we are adding for the purpose of error detection and correction. So we are going to add r number of redundant bits to the k number of data word bits, and this combination of data words and the redundant bits together is called as code word, and that length of code word is referred with a variable called n, which is nothing but the sum of data word length k plus redundant word length r. Okay, so the resultant n equal to k plus r word is referred as a code word, and n is the length of the code word. So what do you mean by block coding? Dividing the message into smaller units called blocks, adding the redundancy bits, and then converting the data words to code words. So first dividing is referred as block, and adding redundant to the data words is called code words, and that together is referred as block coding. Okay, so what we are going to discuss here is, what do you mean by error detection, correction? We are trying to understand Hamming distance, and what do you mean by minimum Hamming distance. So as we just looked ahead, let us look at, I have a data of 5 bits which we have just discussed, and I have divided into 10 blocks, each block of 5 words. So generally how many combinations are possible with this? So I got 5 bits, so totally I can make Generally in binary, for a 5-bit or a k-bit length, I can make 2 power 5, 2 power k combinations. For instance, 5 n equal to or k equal to 5. Then it starts with 0 0 0 0 0 to 1 1 1 1 1. So totally I can have 2 power 5, which is equal to 32 combinations. But this 5 bits, if I am trying to add one redundant bit, now the total length of code word is 5 plus 1 equal to 6. So total length of the code word is 6 bits, and total number of combinations with this n equal to k plus r is 2 power n, which is here 2 power 6, which is equal to 64. But for one code data word, we need one code word. So here, out of 64 code words possible, which is 0 0 0 0 0 0 to 1 1 1 1 1 1, we are going to use only 32 combinations, and the 32 are extra. Okay, so only 2 power k out of 2 power n combinations will be valid in case of code words. So let us try to understand a simple example of 4b by 5b. Here 4 indicates the length of data word k and 5 indicates the length of code word, that is n equal to 5. So 2 power number of combinations of data words is 2 power k, which is nothing but 2 power 4 equal to 16 data words. But now n equal to 4 plus 1, which is 5, and total combinations are 32. But for one data word, only there will be one valid code word. So for 16 data words, we just require 16 code words, but here we have 32 code words. So here what we can say is 16 out of 32 code words are used for message transfer, and rest are used for other purpose, or might be they will be unused. Got it? Okay. Now just we tried to discuss in our previous slide that about how we are trying to implement the error detection in block coding. First step, divide the total message into smaller units called blocks, and the data in each block is referred as data word. So first we'll have a message which is going to be divided into data words, each of length k bit, and using those k bits of data word, we are trying to generate r bits of redundancy, and then we are trying to combine these r bits with, let me just put with a pen. The generator here is going to generate you r number of redundant bits. Okay, so now you are going to combine k plus r, which is nothing but equal to n, and this code words will be transmitted to the receiver. At the receiver, this code words which we have received is forwarded to a circuit called checker circuit. Remember, in error detection we'll do only one function, is whether there is error or not. That is, you will have only two possible answers: error present yes, error present no. So the checker will find whether there is error is present or not. If it is yes, we'll discard that data or the code word. If it is no, then we'll try to remove the redundant bits from this and try to extract the data word. So in the k plus r code word, we are trying to remove the r redundant bits and try to generate the data word of k bits. This is actually the process happens in the error detection. Let us once again put it in simple. Divide the data into smaller units called blocks. In each block, the data is referred as data word. Using those data words, we are generating some redundant bits, adding the redundant bits to the data word and converting it into code words, transmitting the data to the code words to the receiver. At the receiver, the code word is forwarded to checker. If an error is detected, discard. If no error is detected, then try to separate the redundant bits from the data words and forward the data words to the receiver. Okay, this is what happens in the error detection. Okay, we'll take a simple example for error detection. This is my data word, means k equal to 2. Okay, and for this, let me try to make you a simple understanding. We'll discuss about the technique more in detail. I want to convert it into a code word by adding a third bit, which is called redundant bit. And what should be the value of this redundant bit? My criteria here to be used is the total number of ones in the code word generated should be even. That is my criteria. For instance, in the case for here, and total number of ones in the code word means data word plus redundant bits. This, the total number of ones are 0. So what should be the value of redundant bit so that total number of ones are even? Means if I put here it as 1, so total number of ones becomes 0, 0, 1, which is nothing but 1. And that is not even. So I need to set the value of redundant bit here as 0. Then only total number of ones are 0, which is an even. Next case is my data word is 0, 1. Here the total number of ones is 1. But I want even number of ones in my code word. So what should be the value of r so that my total number of ones in the code word is even? So definitely if I put r equal to 0, the total number of ones in the code word become odd. So to make it even, I have to set the redundant bit as 1. Similar with the next one, 0. Number of ones are odd, but my requirement is even, so I place the r as 1. And last case, the total number of ones in 1 1 is already even, so to continue it as even number of ones in the code word, the r value should be 0. So redundant bit is dependent on data word. That is how we are trying to generate the value of r. And data bits combined with redundancy will be referred as code. It's one of the simplest technique for error detection. We'll be calling it as parity check technique. We'll be discussing it short. Okay. Now in the scenario, we'll be having different cases. First we were talking about 0 0, or we'll try to take a case. Suppose the data which is transmitted by the sender is 0 1, and since we need an even parity, what we have to be transmit 0 1 as, it will be transmitted as 0 1 1, so that the total number of ones in the code word is even. Okay. Now for instance, 0 1 1 is transmitted by the transmitter, and the same 0 1 1 is as it is received by the receiver. Now what happens? Receiver forwards this data to code word to the checker circuit. And what is the role of checker circuit? To check if the total number of ones are even or not. And how many number of ones exist here? 2. Is it even or not? Yes. So since number of ones are even, it says that the data is correct, and it will try to remove the redundant bit from the code word, which is generally here the last bit. So we'll try to separate 1, and we'll take the data word as 0. Now second scenario here is when the data transmitted was 0 1 1, but the data received was 1 1 1, means actual transmitted was 0 1 1, but what it was received was 1 1 1. But look at this, when they were receiving 1 1 1, what are the total number of ones? 3. But what is required? Even. So since the number of ones required are odd but we require even, what happens is there will be an error detected, and once an error is detected, we'll try to discard that particular code. This is second scenario. The third scenario that you could observe is you transmitted data as 011 and it got corrupted as 000. But here try to be a bit serious. Let us try to understand here. Observe carefully. What was transmitted was 011 and what was received was it's a burst error, means more than one bit got corrupted during transmission because of interference. But even two bits got corrupted, but total number of ones here are 0, which is an even. So you believe the data was correct. And when you look at the code word 000, it is actually the code word resemblance of a data word called 00. And instead of making an interpretation as error, it will consider the data as 00 and then that will be forwarded to the received. So you transmitted 01, received as 00 and still it was considered as correct. The reason is simple. The parity check will be suitable for 1 bit error detection but will not be suitable for more than 1 bit of error detection. Okay, right. So let the conclusion which we are trying to do is an error detecting code can detect only the type of errors for which it has been designed, and the other types of errors will remain undetected. Okay, so here the parity check is only designed for single bit error, but if it is more than 1 bit error, it cannot detect. That is what we are trying to